Good morning everyone. I'm Uma Maheshwari. In this video lecture series, I'm going to explain about a single sideband suppressed carrier. In the last video, we have seen a double sideband suppressed carrier where we'll be using a two sidebands only without the carrier. Here, with the help of a single sideband, how the modulation takes place will be seen. The process of suppressing one of the sidebands along with the carrier and transmitting a single sideband is called as a single sideband suppressed carrier system, or a simply SSBSC. The carrier and the lower sideband are suppressed here. Hence, the upper sideband is used for transmission. Similarly, we can suppress the carrier and the upper sideband while transmitting the lower sideband. In the side, we have displayed a lower sideband and the upper sideband frequency representation. The mathematical expressions are, as we seen already in amplitude modulation, the modulating signal m of t, the carrier signal c of t is displayed there. By multiplying it with both, we'll get a am ac by 2 cos 2 pi fc plus fm of t. Bandwidth, we know that the double sideband suppressed carrier modulated wave contains two sidebands and its bandwidth is 2 fm. Since the SSB-SC modulated wave contains only one sideband, its bandwidth is half of the bandwidth of the DSB-SC. So the bandwidth of the SSB-SC modulated wave is 2 fm by 2, so we'll be having only fm. The bandwidth of the SSB-SC modulated wave fm is equal to the frequency of the modulating signal. This double sideband suppressed carrier modulated wave uses two methods to generate the modulated wave, that is the frequency discrimination method and the phase discrimination method. In frequency discrimination method, we'll be having product modulator and a filter and the oscillator. Will generate the double sideband wave with the help of product modulator first, and then we'll apply that input to the band pass filter, and finally we'll get a SSB wave. In the product modulator, both the carrier and the message signal which we are giving and the carrier signal is being generated by the oscillator. Then the frequency range of the bandpass filter uses the spectrum of the desired SSB-SC wave. This means that the bandpass filter can be tuned to either upper sideband or lower sideband frequencies to get the respective single sideband frequency. So the main advantages of this frequency discrimination method is it provides sufficiently flat and wide bandwidth. We can have a suitable sideband suppression will be having in this. And the main disadvantages of this filter method are the frequency up conversion at the end is necessary as the system does not generate a SSB at high frequencies. So expensive filter increases the overall cost of the system. Then the next one is a phase discrimination method. Here we'll be having a two product modulators and two phase shifter and a oscillator. Instead of a band pass filter, we'll be having here a phase shifter. Phase shifters, the product modulator produces an output which is the product of two inputs. Then the 90-degree phase shifter produces an output which has a phase lag of minus 90 degree with respect to the input. The local oscillator here is used to generate a carrier signal. Then the summer block here produces an output which is either the sum of the two inputs or the difference of the two inputs based on the polarity of the input which we are giving. This is the output of the product modulator. Mathematical expression is displayed here. Then the phase discrimination method advantages. It does not require a frequency up conversion stage. The modulating signal can be a low frequency or audio signal, and switching between these side bands is easier. Then the main disadvantages of this phase shift method is the designing of phase shifting circuitry is very complex. It also requires phase shifting which wants to be accurate and which is difficult to maintain. Then SSB demodulator. Here will be, it is nothing but the process of extracting an original message signal from the input signal from the SSB wave is called as a detection or a demodulation. A coherent detector is mainly used for demodulating. That is, the same carrier is used to detect the message signal. Hence, the process is called as a coherent or a synchronous detection. Here we'll be having a low pass filter. In the process of generation, we have a band pass filter, but we are here having a low pass filter. So while multiplying the wave with the carrier, we'll be having the same frequency and the carrier phase which is used in SSB modulation. So the resulting signal is passed through the low pass filter. The output of the filter is a desired message signal. The main advantages of a SSB modulation is the power is consumed. It allows transmission of the high power signal. It provides less interference to noise due to the reduction of the bandwidth. The main disadvantages are it is expensive and complex in nature in order to hold this. The main applications are this technique is mainly used for point-to-point communication, and where power saving and low bandwidth is required. It is also used in land and air mobile communication, and it also finds its application in telemetry and radar communication. This is the assessment questions. Thank you.